make a Google Colab, just like we are going to. So the way we're going to do today's workshop is we're going to make a new Google Colab, and we highly suggest you guys do the same. And as we move through the workshop, we'll introduce new methods in NumPy and Pandas, a whole bunch of different things you can do. And as we go through them, you can follow along, or you can kind of like branch off, explore those methods under like different with different arguments, with pretty much anything. So you just got like you just kind of like follow us a bit, and if you feel free to kind of venture out on your own and like explore a bit more, go for it. But yeah, today's workshop is a little bit more free flowing because NumPy and Pandas are really big libraries in Python, and we can't really cover everything. So we've taken a subset of all the things we want to teach, and are going through that today. But as always, like feel free to explore outside of just the workshop.
Okay, so if you follow the link that's in the chat right now, you should get to this form right here. And there are two links on this page. This is the link to our GitHub. So if I open that, this has all the material we're going to be covering today, along with all the data sets. So you can definitely check this out. But like Adithya mentioned, it's going to be way more productive if you guys also make a notebook and work along with us. And we also have a link to an anonymous Q&A today. So if you guys feel nervous about submitting questions through chat, you can use this feature as well. We're going to be checking the chat as well. We're going to get started by actually showing you guys how to make a Google Colab notebook. So I go to Google, I simply search for Google Colab and click the very first link. So let me quickly change my accounts. Yeah, so this should pop up as soon as you click on the link. And what you want to do is then say new notebook, this option right here. And it's creating my notebook. Okay, so this is my notebook. I'm gonna name it workshop _6. Okay, so like I mentioned, the first thing we're gonna be talking about is a library called NumPy. And NumPy is short for numerical Python. And that's because this library is really used for a lot of mathematical and scientific operations. So I'm going to start by giving you guys some motivation for why we would want NumPy. So let's say I have a list. My list is equal to 1, 2, 3. And my objective is to create a new list with the square of each of these elements. Now, if you were using just base Python, not using NumPy, I'd probably have to use a for loop of some sorts, or maybe a map function. So for example, I'd say new list is equal to I squared for I in my list. And I'd get a new list with the squares of the elements I want. So this works, but it's kind of a lot for something as simple as a square. And it's probably a good idea to do operations like this a lot more quickly and a lot more easily. And that's where NumPy comes in. Stuff like this, stuff to do with lists and arrays, are really, really simple. So the fundamental data type in a NumPy is what we call an array. And we often use the term array and list interchangeably, but in NumPy, an array is a specific type of data. So how do we create an array? Well, we can create it by taking our old list, let's say 1, 2, 3, and enclosing it in this function, np.array. Actually, no, before that, let me actually import NumPy. So we often call NumPy np And this is a convention used pretty much everywhere in industry or pretty much everywhere in the world. So if you run this on Google Colab, it'll automatically import this package to you. There's no installation necessary at all. So the way we create a NumPy array is using this function, np.array. And we take the old list, pass it through this function, and we get an array. So you notice the type here is different. It's called an array. And another way we can create an array is something like this. Say I want a range of values between 1 and 10. I do this and I get a new NumPy array. So in this case, we took our old list and cast it into a NumPy array. Here we just create a new NumPy array. And similarly, we can do something like this: a range 1 to 6 with spacing of 2. So it's a start, stop, and step size. Okay. So a really commonly used function is something called Linspace, or linearly spaced values. And the way we do that, let me do it through an example. So we'd have np.linspace, start, stop, and I say number is, let's say let's put 15 values. So what this does through this example, it takes a start, a stop, and asks how many values do you want in this interval. So it'll automatically generate this entire interval for you. Like, remember, if you have like a normal Python function, you probably have another for loop to do this. You'd say, okay, the increment is 0.64285714. I keep adding that to a counter. I keep going through a for loop, accumulating that in an array, etc., etc. But in this case, it's way, way simpler. So it's linspace of start, stop, and number of values. So this is really useful, especially when you want to do plotting and stuff, because it gives you an evenly spaced array. Okay, let me pause here for a quick sec. Does anyone have any questions? Or is anyone having any troubles with Google Colab or anything else?
Maybe it's my settings or something, but in terms of getting the numbers on the side to appear in the automatic like new line, so for instance like the 5, 6, 2, 4, so like my screen doesn't look exactly like yours in terms of like if I click somewhere it'll add a new code line. I don't know if there's any settings you've changed for that or it's just my side.
Okay. Yeah, so the way you create a new code line, right? So suppose I ran this block, let's say print hello. Once I run this, I say shift enter. It'll automatically give me a new cell.
Oh, got it. Okay. Thank you.
So yeah, you're welcome. So yeah, I think I should probably mention the way you run a cell is by typing something out and then clicking shift enter. And that's a shortcut. I mean, you could also run this, but it's much easier to just type shift enter. Okay. It's giving me when I put np array 1, 2, 3. No, that should be correct. Have you imported the package numpy up here? Import numpy as np. Okay, cool, great. Any other questions? So Linspace includes the add value, but array doesn't. I'm not quite sure what you. Oh, a range. Oh,
yeah, a range, yeah.
Okay, gotcha.
And yeah, that's
okay.
That's exactly right.
Yeah, exactly. So Python being a little inconsistent, I suppose, but yeah, that's definitely true. So a range is similar to the range function we talked about last time. It's very much equivalent to base Python's range function. And Linspace, since it's specifically designed to include these upper bounds like this, does include both the endpoints. Why does Linspace give decimal values? Okay, So Linspace is, so Linspace, okay, what we have told Linspace is we want 15 values between 1 and 10. So obviously there aren't 15 integers between 1 and 10. So what Linspace realizes that I definitely want those 15 linearly spaced values. So it resorts to a decimal. So I believe the formula is something like 1 over 14. No, my math is bad. But yeah, it'll basically somehow generate 15 values between 1 and 10. Okay, cool. Any other questions? 9 over 14. Okay, thank you. Perfect. Okay, let's move on. Okay, so a very important thing to do in machine learning is to create random arrays or arrays with random values, because that's usually how we initialize our parameters. So the way we do that, say I want a set of random integers between 1 and 10. I do it like this. So np.random.randint, that specifies that I want an integer, and this specifies the bounds. And I can also do it, I can also say I don't want just one value, I want an entire matrix of values. So I can get a 5 by 5 matrix of random integers. And similarly, let's say I want a bunch of random values between 0 and 1. So np.random.rand always returns something between 0 and 1. So if I want 10 values between 0 and 1, I'll pass in 10 as an argument. Look at the difference here. Here, because it's an integer, we need to specify the range, but rand automatically recognizes that I want something between 0 and 1 only. And of course, I can also create an entire matrix of values like this. So super useful functions, especially for machine learning, and that's the random function. Okay. So then let's talk about some of the really important attributes of NumPy arrays. Now, okay, so let me go ahead and create an array. I call it ARR is equal to np.random. Let's get some random integers between 1 and 10, and I don't know, maybe a 4 by 5 matrix. Okay, let's see what this looks like. Okay, so there you go. We have 4 rows and 5 columns. What I want to do is get some information about what this array is. And by far, the most important function in all of NumPy is what we call shape. The shape attribute is extremely, extremely important. And this may seem trivial that it's, oh, well, it's obviously 4 by 5. But trust me when I say, when it comes to debugging large applications, the shape is going to be absolutely essential. And this is how you access it. So it returns a tuple, the first value being the number of rows, and the second value being the number of columns, as you'd expect. Now, an operation we perform a lot is transposing. So if I have this 4 by 5 matrix and I want to take the transpose and get a 5 by 4 matrix, we do that a lot in machine learning. If you remember from some previous workshops, we take this W matrix, take the transpose, multiply it by X. So we do it a lot. And because we do it a lot, it's very, very simple to do in NumPy. All you need to do is say arr.t, and that gives you the transpose matrix. Okay, and let's say that, you know, I'm just not happy with the shape at all. 4 by 5, it's just not working for me. So what I'm going to do is I'm going to reshape it to, let's say, 2 by 10. So I get a 2 by 10 matrix. And of course, you can pass in any values as long as the total number of values remains the same, which in this case is 4 times 5 or 20. Okay, let me pause again. Does anyone have any questions about these last few things? Can you go over rand? Okay, yeah, sure, I can do that. So np.random.rand always returns something uh, between 0 and 1. I'm not sure if it's inclusive or not, but I mean, it doesn't really matter too much. But it always does something between 0 to 1. So if you look at these values, it's 0.43, 0.17, 0.64, whatever. And it's always between 0 and 1. The difference here is that in the random integer case, I had to specify a range. So in this case, since we know the range is 0 and 1, all I need to specify is the size of the matrix. Is the .rand value .rand only for values between 0 and 1? Yes. So the rand function specifically is for values between 0 and 1. So is it useful for probability? Yeah, absolutely. If you want a random probability matrix, it could be useful. I'm not sure direct application, but like I mentioned, it's extremely useful in machine learning itself because we usually need random values to initialize our weights. Can you return double within a certain range larger than 0 and 1? I believe this is the same syntax for it. Let's see. Yeah. I think the way you do that is a little more convoluted. So let's say, okay. Let's say I want to take random.rand. Let me just get one value for now. The way I would, let's say, increase the interval. Well, let me define a particular point. A random value between 2 and 4. Okay. So just this statement gives me a random value between 0 and 1. So I'm going to shift it by 2. And that should give me a random value between 2 and 3. That's still not enough. So what I'm going to do is I'm going to multiply this by 2. So it's a little more involved, unfortunately, but this will get you where you need to go. It will generate a random value between 2 and 4. Okay. Are there any other questions? Okay, I think we're good then. Let me move on. Okay, so let's see how we can access values in an array. So let's recall our array was this thing right here, this array of integers. And let's say I wanted to access the first element. So it's probably exactly like you'd expect. It's ARR of 0, 0. So what is the row and what is the column? So first row, first column. Similarly, let's say I don't want just one element, I want the entire row. The way I do that is, let's say ARR, 0th row, and give me all the columns. ARR 0, all. So this colon means that pick up all the values along this dimension. Okay. So now suppose I want to create a copy of this array. Well, I can't just say, new array is equal to array, because that's going to be, if I make a change in this array, it's going to be reflected in this array and vice versa. So that's not what we want. So the way we create a copy and kind of de-link the two arrays is by using this function right here, arr.copy. And of course, we get a new array with the exact same values. So this is an important thing to keep in mind as well. If you have a bug, you may want to check if all the values, all the arrays are talking about different things. Otherwise, a change in one is reflected in the other. Okay. So now let's talk about one of those functions that makes Numpy so powerful. And it's a functionality called broadcasting. What broadcasting does is it takes an operation and performs it across the entire array. So let's define a problem. Double the elements in each, double, let me put this one, double each of the elements of the array, right? Now let's think. In Python, of course, double for loop. So I have this massive array here which is a matrix. That's something like for I in range 4, blah blah blah. And we know we're going to need 2 for loops. I'm going to create a new array, store it away, whole lot of mess. In NumPy, the way I do this is this. And that's it. I just say 2 times ARR, and it'll double each of the elements of the array and give me a brand new array. So as you can imagine, this is extremely, extremely powerful. It does away with all of these unnecessary for loops, and all these simple operations which give you an intuitive result like this are pretty much taken care of. So let me show you another really cool application. Suppose I'm starting off with this array, and I want to find out I want to find out which of these values is greater than 5. So I want to create a brand new matrix where the entries represent whether the value is greater than 5. So I go over this, I say, is 8 greater than 5? It's true, so I put a true value here. Is 5 greater than 5? No, it's false, so I put a false here. Is 2 greater than 5? It's false, so I put a false. So again, in Python, I would use a double for loop. But in NumPy, what I can do is I can just say ARR greater than 5. And NumPy will automatically realize that, hey, this guy's trying to find out whether every element is greater than 5. So it'll automatically generate this matrix for me. Oh, I see I missed a question in the chat. Does it change the array or create a new copy? Yeah, so 2 times ARR isn't, so it's not going to change the array. So I already ran that cell. It's going to keep the same array, but it's going to return a new value. So I can say something like new array is equal to 2 times ARR. And my new array is saved out. So this is basically like almost like a function which returns something to be captured by a new variable. Those simple operations are vectorized in a more efficient language, right? Yeah, so I'm not sure about the details of implementation exactly, but that is the basic principle. All of these operations like broadcasting are extremely, extremely, extremely quick in NumPy. I mean, I haven't benchmarked it here, but you can get like a 400 times increase in speed, so which is obviously very, very, very useful. But yeah, the process is called vectorization, which has to deal with these objects called vectors. So yeah. Are there any other questions? Actually, let me show you one more operation before we go on to questions. So suppose I don't want to just find out whether the values are true or false. I want to actually extract these values, which are greater than 5. In NumPy, that's really, really simple. I just say ARR of ARR greater than 5. So it selects the elements of ARR such that ARR is greater than 5 in a very, very intuitive manner. And it gives you all the values you're looking for. Again, in Python, it's a double for loop, and this is way, way faster. Oh, I see, I missed another question. These operations are all NumPy specific, right? Not Python? Yeah, absolutely. This is all very, very much specific to NumPy, and moreover, it's specific to this type, which we call an array, which is different from the list type. Okay. Yeah, any other questions? Is there an implicit for loop when running? You say ARR greater than 5. Okay, let me read that out a little more clearly for people watching. Is there an implicit for loop running when you say ARR parentheses ARR greater than 5? So this operation right here. And the answer is technically no. NumPy isn't implemented using for loops. So it's implemented through a process called vectorization, like you mentioned. But if you want to think about it intuitively, then yeah, sure, you can definitely think about an implicit for loop. But it's important to note that this implicit for loop is way faster than any for loop that we could code up. So it's important to make that distinction. But sure, if it helps with intuition, it's fair to think about it as an implicit for loop. Okay, any other questions? Okay, so let's talk about some other math functions. So suppose I have my array, and I want to take the exponential of each of the elements in this array. So again, I want to stress this once more. In Python, you need a double for loop to handle this. In Numpy, we simply say numpy.exp of ARR. And that'll give me, let's say, a new array. This is equal to np.exp of ARR. And like you'd expect, did I mess up?
I think there's a space in. It's like new underscore space array.
Okay, yeah, I could not see that. I'm bad. Yeah, okay, cool. So this applies the exponentiation operation to every element of the array, like you'd expect. And this is very useful. Like we'll see later, we're going to try and implement the softmax function that we talked about in an earlier workshop. And this function is going to come in handy. So similarly, something else, let's say new ARR is equal to np.sign of ARR. So this would apply the sign function to every element of the array and give me a new array. Okay, so some other commonly used functions, let's say, oh, so we have a question. What is the exp function? Oh, sure. So exp performs e to the power of every element in the array. So e, when I say e, I mean the value 2.718, blah, blah, blah. Yeah, cool. So yeah, it takes e to the power of every element in the array. So let's see some other functions which are really useful. One of them is, let's say you want to calculate the mean of the entire array. So we say np.mean of ARR, and it calculates some value for us. But now let's think. This value has been calculated for all the elements in this array. So it goes over all 20 of these elements, sums them up, divides by 20. Let's say instead that I want to calculate the mean of each column of this array. So I want to go over this column, calculate its mean, store it away, go over this column, calculate its mean, store it away, and so on. Obviously, this is a pretty intense operation, right? I mean, it's going to be pretty annoying to implement in Python. But in Numpy, the way I do that is like this. np.mean of ARR axis equals 0. So what this is going to do, it's going to do exactly what we just talked about. It's going to say calculate the mean along this axis. And that's really powerful. As you can imagine in like data science or something, when we're calculating the mean of all these gigantic matrices, a function like this is going to be really handy. And of course, this will apply to anything like standard deviation or the max or the min or anything else you can think of. So this is a really powerful function. Okay, are there any questions about any of this? How this function works or anything? Can you specify what axis? Two-dimensional matrix. So we have a 0th axis and a 1 axis. So in this case, we can specify an axis to be either 0 or 1. So in this case, if I say axis equals 1, it'll calculate the mean of all of the rows instead. Okay. Is np.mean of ARR the mean of all the entries? Yes. So if I just say mean of ARR and don't specify any axis, we calculate the mean of the entire array. When we have higher dimensional arrays, how are axis numbers assigned? Okay, that's a good question. So, suppose I want to create a new array. It's called my 3D, I can't say that. Let's say my tensor, okay? And I'm going to say the generated with random values of 3 by 3 by, okay, actually no, let's do this, 2 by 3 by 4. So I get a tensor of this size. Obviously, oops, my bad. Yeah, so I get a tensor of this size. Now, the way it works, the axis numbers are specifically assigned depending on how you've defined the array. So there's nothing arbitrary about it. It's specifically how you define it. So the axis number 2, in this case, is going to refer to this, we could call it the third dimension, which contains four values. So by specifying axis equals 0 or 1 or 2, I can choose which dimension I want to access. So it's completely dependent on how you've defined the array. Okay, any other questions? Okay, then let's move on. Okay, so the next thing, let's try and take all of this knowledge that we just got and apply it to an actual problem. So let's try implementing the softmax function that we talked about from the workshops. If you recall, the softmax function, we use it in multi-class classification. And it's really useful if you want to calculate the cost. So the way it works is it takes in an array, calculates the exponential of each of the elements in the array, and divides that exponential element-wise by the sum of the exponentials of all the elements in the array. So as you can see, it's a pretty intense operation right here. So let's first try programming this using just Python, using only Python. Okay, so how would that work? So let's say define a function. I'm going to call it softmax because I'm really creative that way. And I'm going to start off. So I'm going to first calculate the exponential of each of the values of this matrix. So let's say xz, I'm going to call it xz, is equal to 2.718 to the power I for I in z. And this should calculate the exponential of this matrix term by term. Then I want to calculate the sum. So let's say S is equal to sum of xz. Then what I want to do after that is the more tricky part. So I want to take this matrix and generate a new list with the elements of this list divided by this term S. So let's say my output is an empty list initially. And I can say for I in xz, output dot append I divided by S. And let's return this output. So this is the very hard-coded implementation of what the softmax should be. It's explicit, so it tells you exactly what it is. Create a new list with e to the power I for I and z, create the sum, and divide each of the elements. So hopefully this works. Let's say, what is our value here? 3, 4, 1, and 2. Yeah, and it gives us the output we expect. 0.24, 0.64, 0.03, and 0.09. So it works. But let's be honest, this is quite a lot of effort for a relatively simple function. And I'm not a fan of all these for loops flying around here. That makes stuff really, really slow, especially if z was like 10,000 size. So let's see how we could do it using NumPy. The way I do it, I'll define my function again, softmax of z. If you recall, the way we do that in NumPy is simply np.exp of z. And that's it. If I want the sum, it's obviously the same thing, np.sum of exp. Now here's the clever part. So this was the most intense operation we had. In NumPy, what we can do is we can say the following. Output is equal to xz divided by s. And that's it. So this will automatically use broadcasting and take this old array, divide it term by this sum, and return the output. So all of this functionality that we saw here gets completely hidden away and optimized in this operation here. So let's run this and say soft max. Now I'm going to pass in an array, which was 3, 4, 1, 2. And let's see if it works. I see the messed up. Soft max of, oh, sorry, my bad. Yeah, done. Yeah. So the mistake I made was I forgot to create a list first and then cast it. So actually, you want, let me separate these two steps. Let me say z is equal to 3, 4, 1, 2. And I'm going to say np.array of z. So this gives me the exact same value and a lot faster and a lot cleaner. So it's a pretty useful functionality. So if you want to define this in exactly one line, something like this. So we can say return np.x of z divided by np.sum of np.x of z. So this complicated looking function is implemented in one line of code using NumPy. So that's pretty cool. Why do we have to declare z as an np array as the input parameter? Okay, so that's true. We don't exactly need to define it as an np array. Using this function will automatically convert it. But the reason I wanted to specify it is to point out that we're going to be using NumPy arrays. And in fact, in machine learning or data science or anything, you're going to be dealing with NumPy arrays in the beginning. So I wanted to just show that we could pass through NumPy arrays through this function. But yeah, very technically, you could pass in a list and it will automatically convert it. But it's probably a good practice to make sure you know what your types are. Okay. What functions can you broadcast on an array? So the list is very long. And pretty much everything you can think of intuitively would probably be implemented. I suggest just looking it up in the documentation. But before you do that, I'd say give it a try and say it'll probably end up working. So it's really powerful and pretty expansive. Okay. Are there any other questions about anything we just covered about softmax or anything else in NumPy? Oh, would the one-line version of softmax be less efficient since you're calculating np.x per z twice rather than calculating it and storing it in memory? Yes, that is true. That's very true. So in this case, you perform this operation just once. In this case, you perform it twice. Of course, in this case, it really doesn't matter because we have 4 elements. But yeah, it's a good programming practice to, if you need to use a value more than once, store it away. So right, you're absolutely right. This is probably going to be a lot faster than this. Okay. Any other questions? Okay, I think we're good then. So I'm gonna hand it over to Adithya now, and we can talk about Pandas, which is another library in Python.
Yeah, all right, cool stuff. I guess, yeah, before we begin, we can take like a short, like 2-minute break, because we definitely covered a decent amount. yeah, once that's done, we will continue with Pandas, which builds on top of NumPy.
And yes, to your
Uh,
question, this document, yeah, we're going to upload this document on our GitHub page as well. So definitely check that out. So all of this extra stuff that we mentioned, all the stuff we talked about, is going to be on the GitHub as well. Cool.
yep.
So we're going to get set up with the next notebook. In the meantime, feel free to import pandas and get started. And of course, ask any questions.
All right. Okay, I hope everyone can see my screen. I hope everyone can hear me right. We'll get started with pandas now. So again, you can import it like this. Import pandas as PD. Once again, that's just the convention we use. You can technically import it as anything you want, but PD is the convention. Yeah. So pandas is very important when it comes to more of data analysis and trying to like manipulate data. NumPy is really good for these sort of array operations as we just discussed, but you use pandas when you have like a massive data set and you might want to, let's say, change some values around. Maybe you want to completely exclude certain columns, certain rows. Um, Whenever you're dealing with big data, that's where pandas comes in. It's especially useful when you're in the phase of cleaning up data to use in your machine learning model. Pandas is super useful then. And once you're done with that, that's when you kind of use NumPy to like do these sort of operations like softmax and whatnot. So yeah, and also just to reiterate, pandas is technically built off of NumPy. So a lot, you can expect a lot of the features that exist on NumPy to also exist within pandas. But obviously there's going to be certain differences. We'll look at them today. So pandas has two sort of main data structures. So they have something called series and this other thing called data frames. You can think of series as NumPy arrays, but with a little bit of a twist, and we'll get into it. So this is how you declare a series in pandas. Um, pd.series, and your first argument is a list of um, anything you want. I'll just go with that for the time being. And this is where things get a little different. You also have to provide an index. So with NumPy arrays, you kind of just pass in a list and you're good to go. The way series are different from NumPy arrays is that each sort of value in a panda series has a corresponding index. Um, and the index, you'll understand why this index is important when we take a look at data frames, which are essentially is a whole bunch of series brought together to create like these sort of like really large 2D matrices. You can index series to get like a particular value from the series. So you can say series A to get 1, You can't do it the other way around. You use the index to access the value. You can't use the value to access the index. So yeah, let's go ahead and make another series real quick. And let's see what we can do here. Data. And we'll kind of just stick with the same index that we had. All right, so this is our, all right, yep. So this is another series. So the good thing about series here is you can do these sort of element-wise operations on these series. And for that, you kind of need to have these sort of series that have the same index, and that's important. So I'm gonna make these the same index. Whoop, need to have a corresponding value for that. So this series has indices A, B, C, D, E, and values associated with them. And this series also has the same index. And the good thing about stuff like this is you can now add these series together, just like you would another series plus some series. And it kind of just spits out this new series right back at you. A little bit trivial right now, but again, as I said, once we begin looking at data frames, which are like these sort of main data structures that Pandas uses, we'll kind of get a better understanding of why this is so important. So, all right, let's do this real quick. Let's make a data frame. I'll just copy paste the sort of declaration for these things because they're a little bit um, long and we don't need to waste time kind of declaring it, but I'll explain I'll explain exactly what we need. So data frames, you call it using PD data frame and you have data and index just as in series, but this time you also need to include columns, and that's because data frames are essentially 2D matrices. And in the same way, you can use the index to identify each of the rows in this data frame. You also need to have column labels to declare, not to declare, but to identify the different columns of the data frame. As you can see here, we used NP array. I've not used that, I've not declared it, but the cool thing about this is you can actually use NumPy arrays um, to pass data into data frames. So I'll just quickly go ahead and make a new NumPy array. Just like that. And once we take a look at this data frame, oops, see. Right. All right, there we go. Yeah, my bad. I declared the NumPy array, but I did not reshape it to be a 10 by 10 matrix, because if you look at the index and columns, we have 10 rows, 10 columns. The data you pass into this call to make a new data frame needs to match and have the exact same dimensions. Wait, there's a few questions. I forgot to look into this. Okay, seems like Sudhanshu got most of it. Can you add series that have different lengths? You can. It is not recommended. And the reason for that is when you add series of not just different lengths, but series that have different indices, when you kind of add them together, it creates like this new series which combines both this values from one series and the other series, and it's a little convoluted. You don't It's not as Sudhanshu said, it's not great practice, um but yeah. How was NumPy array initialized again? Yeah, so we kind of covered this with Sudhanshu. We went np.random.randint, and as we said before, randint gives us back a random integer. I initially said I want those integers to only be between 0 and 99, and I want to get 100 of those integers. And that call itself only gives us an array, which is essentially just 1 by 100, um, 1 by 100 matrix, you could say. I had to reshape it to form a 10 by 10 matrix because the data frame I am declaring here has 10 rows and 10 columns, as you can see over here. I had to reshape it into this new form so that it could be valid data for this data frame call. So yeah. Cool. All right, let's move on. So, well, what can we do with data frames? So a few simple operations. You can get columns, right? Just like that. And this is kind of where I was talking about how data frames are just a whole bunch of series is put together. This is just a series, as you saw over here. It's in the exact same sort of form. Columns and rows in data frames are series, and any of the operations you can do on series can also be applied to the individual series and individual rows of data frames. What else can you do? And yeah, just to kind of just prove that these are still series, you can do type of what this is, type of DFA, and it's just a series. If you want to retrieve rows instead of um, columns, you can't just do DFA. That's not something you can do. Instead, you got to do DF location of A, and that gives you the series corresponding to the row of A. And as you can see, the index values change to reflect the column labels appropriately. Here, when we were kind of retrieving columns, you had the row labels to identify each of the values. Yeah. All right. So pretty simple. I guess, yeah, just a little bit of a tidbit of information. This not really used that often, but you can also use iloc, which is ilocate, which you instead of passing the label for the row, you can instead pass the row number, starting from 0. Um, Not really used as much. This is using the row label is always a little bit more, it makes a little bit more sense than using just numbers, but you can also do that. Just FYI. All right, cool. Let's make a new, you know, let's add a new row, a new column to the data frame we just made. So here's how I do this. We say df z, and that does not exist yet. And Pandas knows that. It doesn't exist as a column here. So whatever we equate this to, it's gonna make a new series and kind of just append that series to the data frame that we made. So pd.series, and as you can see, data is just a random integer, 10 random integers between 999. And again, index has to be the same if you want to add it to this data frame. If you want to see what happens when the indices are not the same, go ahead and try it out, and you'll see what goes wrong. So yeah, running this, you can see that, yep, we do have a brand new column here, Z, with a whole bunch of new values. Again, this would be useful if you want to kind of have a new column that you create based on the values of previous columns. So this kind of have you add new columns. Making a new row is a little bit different. So let's see. I'll create a new row. So I declare a new row here, which is again a series. And this time the index needs to be the column labels, not the row labels. And once we create this new row, you can go ahead and just do df.append new row, and ta-da, there you go. We have a new row here. And as you can see, its name is Z, as we've specified here. Yeah, so that's those are like just pretty simple operations you would do to add or remove rows and columns. Well, we already discussed adding columns and rows. We'll also discuss removing them. But yeah, this is a real just sort of simple introduction to data frames. Are there any questions? Put them in chat, speak out, anything's fine. So please share to where exactly. You can just mention this to when you initialize the DF at the beginning. All right, sure. Right over here. Yeah, exactly. So index are row labels, columns are column labels. You can think of them. You can think of them like that, exactly. Another good way to remember them is when you create a series, you need to pass an index. And these series, you can think of them as just a collection of rows. And these index values are just the row labels, and the column values are just the column labels. So yeah. How do you drop rows and columns again from? Yeah, so we've not discussed that yet. So we're about to get into that. All we've done is add rows and columns to data frames. All right, is declaring the name necessary when running the functions like index or columns? Declaring the name necessary. So it's only necessary when you like when you create a new row. And the reason for that is the way Pandas adds rows and columns to data frames. So as you can see here, when we were adding a new column, we specifically say we want the data frame and the Z column, the Z labeled column, to be this new series. And it's that's kind of how Pandas understands, like, oh, the name of this new column, the label for this new column is just C. When we add a new row, that's kind of where we have to specify what the name of this new row is going to be. The name is essentially just a label, because there's no real explicit like, hey, I want DF of this row to be this new row that I've made. It's you just append rows to data frames. So when you declare the series, you need to assign it a name. Can I just pass Z instead of the name Z as an argument, for instance? I believe you probably cannot do that. We can try it out. Yeah, no. So name Z is not. Oh, you mean like can I just pass Z instead of name equals Z? Yeah. So the problem with that is you will need to keep in mind. So with Python, you can kind of just pass in these arguments into functions without really specifying what that corresponds to. But I always feel it's better practice to explicitly say what you're passing in, because the issue with not specifying it is then you kind of need to take into account the order in which the arguments need to be supplied. And there's a lot of room to mess up in that case, because sometimes you might have something else come before the name argument when creating a series. So in just in general, it's just better to especially for complicated things like this where you have these series with like these long sort of arguments. It's just better to kind of like specify exactly what the argument is. um, there's no harm in doing that. So yeah, but yeah, you can definitely pass in just Z instead of name equals Z. All right, cool. Let's talk about dropping or removing rows and columns. So pretty simple. df.drop. And you kind of just mention the row you want to drop. And once you run that, oh, whoops, my bad. Um, what is going on? Give me a second. Um,
I think we redefined our
oh,
arrays,
yeah, we
our layer
redefined
filter.
it, right? Yeah,
Yeah.
okay. I'll just go ahead and run everything. Wait, Sudhanshu, do you know how because I don't really use Google Colab, how do you run everything till a particular cell?
Sure. So let's say you go to a particular cell, click on that cell, right, and go
Mm-hmm.
to the runtime tab right at the top.
Or runtime and run before?
Run before. Yep.
All right,
So
cool.
that'll run all the cells before that cell.
Yeah. Yeah, just a good thing to know in general for everyone. Um, especially when you load in a new notebook, and if you want to just continue working off from where you were, you kind of need to run all the cells before that new cell before you continue working. So yeah. So here we go. This time it will work. What in the world is going on? All right, give a second to troubleshoot.
Maybe try like A or something. Like one of the ones we know it should be that.
Specifying the axis. You usually don't have to do that because
Yeah.
it automatically assumes the axis is 0. Okay, yeah, this is, oh no, let me try axis 1. Okay, there we go. I don't know why that was not working. It should have worked. But yeah, I guess this is where you kind of like specify, kind of talk about what this axis is. So you use df.drop, and you give it a label and an axis. And what that does is it looks at an axis, and you have two axes, 0 and 1. 0 corresponds to rows, 1 corresponds to columns, and when you do specify an axis, it it's weird. It usually, what you can do is it defaults to 0. So when you, all right, it worked now. This is just weird. But yeah. So yeah, you can, when you don't specify an axis, it automatically assumes it to be 0. That's the default argument. And that'll drop the row A. But the thing is, right, if you go ahead and show df once more, A is still there, but we removed it. And this is where things get a little bit more trickier. And this is where a lot of people oftentimes make mistakes, I've seen. They usually forget to specify the in place argument. And the in place argument says that you pass to a function like drop, essentially says like, hey, drop the row or the column that I tell you to, but make sure that applies to the data frame that I'm calling this function on. So in place equals true basically means like, hey, drop A of the data frame that I'm calling this function on, make sure that it's in place, that the changes remain in place. And when you do that, and you call df once more, um, the A is gone. Um, so yeah, again, you can, the way you wanna remove columns is you gotta specify the axis to be 1. The way I like to remember it is 1 is kind of tall and refers to columns because columns are tall. Well, that's just how I do it. I find that a little bit more easier to remember. But yeah, and once again, you can mention in place equals true, and oops, dot drop. Don't forget that. And call df once more, and the B is gone. So yeah, real simple operations, removing columns, removing rows. All right, let's move on. df greater than 50. What does this give us? It gives us another data frame, true and false values still. Basically saying like, um, if each value in the data frame satisfies this condition. Not really useful, could be useful in certain cases, but not that useful. What we can do instead is this. The best way to read this is give me the data frame where the condition that the data frame value is greater than 50 is satisfied. That's how I like to kind of like say this in my head when I type it out. And what you get is the values where this condition is satisfied, and all the values where it isn't, it just puts NaN null. And yeah, and the reason why this is powerful is since you have all these null values, what you can do is you can do something like this, where you say, hey, do this fill and anything and do something like this. And the cool thing about this is it takes all the values in any data frame that are null or NaN and fills it with the thing you tell it to fill it with. So right now I fill it with this, but it could also be numbers. It can be pretty much anything, anything you want it to. So yeah. Um, so those are just a few pandas operations. We're going to start looking at how pandas is useful for exploratory data analysis, and we're going to look at some data sets for that. But before we do that, are there any questions? Okay. Are the elements where it says NaN equal to none? Yeah, essentially. But to confirm, we can go ahead and try it out. df of 0, 0. Um, okay, that just gives us back a data frame. But yeah, it does that it's essentially a null value. It's a none, which is Python's version of null. How do we get the df to say true or false versus val versus NaN? Yeah, so the way we did that is while I scroll to the drop row code, yeah, that's how you drop the row. Um, the way you say df to say true or false rather than val versus NaN is when you just specify condition. When you specify condition like df is greater than 50, for example, that's when it gives you back. Okay. Yeah. So for people who are asking, NaN is not a number. Um, just to put that out there. And yeah, to get the true versus false thing, you just have to supply a condition. Once you supply that condition into a data frame using using the square bracket notation, that's when you get the NaN versus actual value data frame. So yeah, can you put a string in fill in? Yeah, we actually just did. Um, um, right there. You can put a lot of things. Uh, yeah, integer strings, whatever you want. Um, one thing that might be good to know when you do this, I'm not sure if this is the case. It might not be, so I'm not gonna say it for sure. But I don't know if filling the NaN values with a string converts all other values to strings. I'm not sure on that. Don't quote me on it. Um, but yeah, I'm not sure about that. But that's always something you guys can look up when you get the chance. All right, so let's go ahead and yeah, begin with a data frame, and I guess we can go to the GitHub for that. Um, so if you guys head on over to the GitHub page that had all these notebooks, you can you can see these two data sets. Let's look at it. All right, yeah. So yeah, if you go to workshop 6, we have these two CSV files that we're going to use as our data set that we're going to work on. So we'll start with the student performance data set. Open it raw over here. And the reason for that is now we have the file, the raw file. And the good thing with this is you can kind of copy this link, and the way you read in a data frame, read in a CSV file into a data frame is this function, read CSV. And right here, you can kind of just go ahead and plop in um, the link to the file. Oh, well, not df pd for pandas. Derps. Yeah. So we've now imported this. Does anyone have any issues with doing this? Please say it right now. We can deal with those issues now, and if not, we can continue.
How do you read something in raw again?
Say again.
How did you open up that file type?
Oh, okay, this one. Yeah. So the way you do that is go to that particular file. You should be able to see this this raw button here on the top right. Just click on it.
Okay.
And be able to open it here and copy the link for this file, everyone, if anyone's facing issues. Yeah. The read CSV file command is a lot more than just what I'm showing you right now. There's a whole bunch of arguments that you can pass into read CSV that you could use to kind of manipulate the data as you read it in. Um, we won't get into all that right now, but when you get a chance, guys, go ahead and check out the documentation for pandas. Really, really in depth, really useful. Always a good thing to do. All right, let's begin. So for large data sets, you don't really want to kind of show the entire data frame. It's not good practice. So we have the dot head the dot head method, and what that does, it kind of just shows you the first few rows in our data set. So as you can see here, a few rows, a few columns: gender, ethnicity, parental level of education, and so on. And a more And to get a little bit more info on each one of these, you can do students.info. And this gives us a really useful sort of summary of the data that we just imported. It gives us all the column names and the non-null count, which is essentially just how many values in each column that are not null. And it's good to see that we have 1,000 entries. All the 1,000 have some sort of value associated with them. They're not all null, which is great. It's a pretty clean data set then. All right, let's look at some. Okay, does anyone? Yeah, first off, does anyone have any questions regarding anything we just did, importing the data set, all that stuff?
I'm just getting an error when I try to copy and paste in my data set. Did you?
So did you go ahead and pd.readcsv is the name of the method, and then you kind of have to copy paste the link to that raw file in as a string into the as an argument.
Okay, that's what I did, and it just comes up with function object is not subscriptable.
Huh. Wait, you also, oh yeah, so you have imported pandas as PD, right?
Yeah. Oh, is it bracket or parentheses for it?
It's parentheses.
Oh, okay. My screen had it blurry. That's probably it. Thank you.
Oh, gotcha. All right. Yeah, no problem. No problem. All right, cool. Yeah, let's move on. Let's say you want to find all the number of male students in this category. So let's take so the way you would kind of approach that sort of situation, like how do I count all the male all the entries that have male associated with the gender. Um, the way you do that is you can first tap into this gender column and say equals to male. And when you run this in itself, it just gives you a series with false and true that corresponds to every single one. So as you can see, 0 is false, 1 is false, but 3 is true. That's not very useful for us. We want to do this a little bit better. So we can do kind of put this entire thing within a data frame. The students brackets, square brackets this time, and put in the condition here. And we've done this before, if you remember, with df, where df is greater than 50. It's essentially the same situation. Any condition you should always put conditions within these square brackets as such, so that it gives you a data frame back. Now this is a lot more useful because now it only gives you the rows that that have male as the value in the gender column. And this is great because now you can see 482 rows. Oh, wonderful. There are 482 male students in this data set. But sometimes you don't get this 482 rows and 8 columns. It only tells you that because we're using this nice interface in Google Colab. But the complete way of doing this is once we've gotten this new data frame consisting of only male students, we want to tap into the gender column, and when we run that, we get the series consists only of male students, and then we just call count on it. And this just straight up gives you a number 482, which is the number of students. That's just the entire process, and I hope it gives you an idea of how you kind of have to approach these sort of questions, like, oh, how many male students are there, or how many I don't know, how many people have standard lunches versus free or reduced, all that sort of situations. So yeah, let's 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 tackle another question. What is the average sort of math score here? Um, so the average math score, obviously we wanna sum all the values in this column and then divide by the number of values in this column. And that's a pretty simple approach. We first tap into um, the math score column, and we just call sum on it. Because remember, each column is a series, and the great thing about series is you can call these sort of aggregate functions similar to how you call them on NumPy arrays, because Pandas series are just built on top of NumPy arrays. So stuff like sum or stuff like count can be called on Pandas series. So students math score.sum just gives the sum of all the math scores. We want to divide this by the students math score dot count. And that gives us 66.089, which seems about right. So yeah, we can let's take a look at another sort of question you could be asked by an employer or whoever as a role as a data scientist. Let's say how many sort of ethnicities are there in this data set? Well, there's a pretty convenient method for that. You first need to tap into the, the column and then just call unique on it. And what this does, it just gives you an array back consisting of all the unique values within this column. And this is especially useful for columns that um, tend to have certain values like female, male, like lunches, standard or free slash reduced, all that sort of stuff. Uh, if you want to get the number of unique, just put in an n there, and that just tells you the number of unique values you would find in this column. All right, let's quickly talk about this uh, this sort of data structure. Well, not a data structure, sorry, an object. It's called a group by object. Students by ethnicity. Dot group by. All right. What this does, and if you just call this as it is, it's not that useful. What it tells you, it's a data frame group by object. What that is we've converted the data frame into a sort of type that we can now call a whole bunch of different functions on. And all of these functions are going to be grouped these functions are going to be grouped by ethnicity, and a really good way to just show this is by doing something like let's find mean. And what this does is it first groups all the students by race and ethnicity, and then calculates the mean for any viable sort of columns. So you would apply the mean, you would apply a mean sort of um, command to a series consisting of numbers. And that's exactly what we see here. We have math score, reading score, writing score, and the mean values for each of those by the ethnicity. And you can kind of see that it's displayed in a nice sort of compact way here. You can do a whole bunch of other things. You can do stuff like um, students by ethnicity. We could tap into the lunch column, and we can do something like value counts. What that does is gives us again, once again, each of the groups the number of the standard and the free or reduced lunches. And all this data is given by the group. And again, this is why it's called a group by object. It groups all these sort of columns, all these other columns by another column. So we apply this group by object on the ethnicity column here, and now any of the functions we apply kind of groups all these other columns by the ethnicity. Um, uh, Group by objects are very powerful. They have a lot of applications in data science, data analysis, especially when you're looking at these sort of distinct and discontinuous groups, and you want to apply functions like mean, value counts, a lot of different aggregate functions to kind of figure out how the data looks by a particular by according to a particular group. Okay, so I see a question here. So it changes a column to an index. Huh. Um, I've never thought of it like that, but if it does help you, uh, it's a good way of thinking about it for sure. But these sort of functions like mean or value counts, you I guess you could say they're aggregate functions. So either way, if it helps to think of each of as this group by object to index based on column values, I guess, then yeah, absolutely go for it. If it gives you a better idea of thinking about it. Once again, look at the Pandas documentation on it. Um, it has a lot more information than what we can show right now. So yeah, let's move on. Um, a few other real simple sort of um, like functions, methods that we can call. Let's say we want the minimum writing score dot min, another function that you can call in a numpy array. Same thing here. We can do the similar thing with um, max, as we see here. Oh, and yeah, all right, let's wrap up this particular data set because we still have to get to the other data set, but um, let's think about this situation. We want to find the number of students who have standard lunches, were female, and got more than a 60 on their reading scores. So very sort of narrow look into the data that we have. Um, let's think of how we can approach that. So first thing we need to do is find out how many of the students were female. Once again, we've done that before. Students, gender, equals female. We also want to find, wait, I guess I can go ahead and copy the question in so that you guys can better understand what we're doing here. So yeah, how many students had standard lunches, were female, got more than a 60? So these are the situations that we need to do. So we've covered students that are female. We need to find how many students had standard lunches. And the way we do the AND operation when we're talking about these conditions for data frames, we can't unfortunately use the normal AND. We need to use the ampersand like that. That's just how it is. And the next situation we need to find is how many of them had standard lunches. So once again, we can go lunch equals standard, and the number of students who got more than a 60 on their reading scores. So that again, student, tap into the reading score column and greater than 60. All right, running this, not that useful. Once again, it just gives you a series. As we said before, all these sort of conditions you want to put within these square brackets. And once we do that, this is great. Now we have um, the data frame that satisfies um, all of these conditions. As you can see, there's 292 rows here. So that means 292 entries satisfies the conditions that we've provided. But again, it's, as we said, always good practice. Let's tap into the reading score column and call the count function. And what that does, it gives us the actual value back, 292. We're good to go. Yeah. We're gonna go to the next data set a little quick because we're running out of time. So yeah, let's go ahead and do that. So let's import the next data set the exact same way that we did for this one. Let's go here. The raw file, and yeah, in the meantime, if anyone has any questions, feel free to ask them right now. All right. Everyone should have this run. And once again, let's take a look at the head to kind of understand what we're dealing with here. Cool. There's a lot going on here. Let's look at the info as well. Always good practice to run these two commands after reading data into a data frame. And we can see here a few things, a little information about what we're doing here. All right, so it seems like the notes column, a lot of non-values. Yeah, all of these are null. There are 0 non-none values here. So what we can do is real quick, we don't need it. We can just go ahead, drop notes axis equals 1, because again, we're dealing with, this is a column. So we need to specify that the axis is 1. And we want in place to be true. And running this removes the notes column because we don't really need to deal with it anymore. So yeah, it's gone now. Let's move on. Let's take let's take a look at this. Who is the highest paid right here? Because this Data set consists of salaries. All right, how do we find the one who's the highest paid? Okay, so again, it is um, we need to take a look at this total pay plus benefits column right here. That's essentially the overall pay that a person receives. Um, and we want the condition here is we want to find who's the highest paid. So we want to find the max of this particular column, dot max. Great, this is a condition. It literally gives us one true value because it's just there's only one person who has the maximum. But again, the better way to approach this is all the conditions, put it in the square brackets. And now we get this person. This person is the highest paid overall. That's how you do that. Let's see. Another question. Who are the, not who, sorry. What are the 5 highest paying jobs? All right, yeah, so we won the 5 highest paying jobs. Let's tap into that first. So job title, and let's look at value counts. And what this does is it value counts with an S. And as you can see here, we have essentially a Panda series consisting of all accounts for each of the job titles in the data frame. We can kind of get what the top 5 highest paying jobs are, but if you want the top 10, for example, you can always do something like this, and it just gives you the top 10. All right, and finally, let's look at how many people have the word captain in their titles. So this one's a little bit more in depth, and the way we're going to approach this is we're going to look at cells, and we're dealing with job titles here. So let's tap into the job title column, and we want to find the number of people who have captain in their title. And this is a good situation where we can use the dot apply function. What the dot apply function does is it applies the functions we provide as a parameter to every single entry in this job title column. And the way we can approach this is, so we can do something like define find cap, where we take the title in as the argument, and we can just return, since this apply function applies this find cap function to every single entry in the job title column. What we can do is we can just say return captain in title. And what this does is it just checks to see if the word captain is in the title, which is each of the values in the job title column. We can go ahead and pass in find cap into apply. What we get here is once again a series, but that's not super useful. So we can sum it, and we get 411. Which is essentially the number of people who have captain in their job titles. So yeah, all right, we have a question here. How does calling value counts find the highest paying jobs? Find the most common jobs. Um, oh, did I say highest paying jobs? Oh, that's my bad. Yeah, I was, I don't know. I was supposed to be the top five or the five most common jobs. Yeah, my bad, guys. Um yeah, in my head I was trying to find the top most common jobs. If you want to find the top five most highest paying jobs, take that as homework if you want. But yeah, um that's about it for pandas. I know this was super rushed because there's a lot going on with pandas. And I wish I could spend more time to explain things a little better. But again, this is a smaller workshop. It's a short workshop, but yeah, it's pandas, NumPy, both are really useful data analysis tools. And they have a whole bunch of applications in the data analysis field. Any data scientist would know how to use NumPy and pandas. So so yeah, having the ability to say that you know how to use pandas and NumPy efficiently and properly is a really cool skill to have, not just when it comes to machine learning, but just in any general scenario. So yeah, that's about it for this workshop. Um, and yeah, the feedback form is the link to the feedback form is in the chat. Please fill that out. It really tells us if we're going in the right direction when it comes to teaching you guys. Um, and yeah, thanks for coming out today, guys. Again, if you guys want, anyone who wants to stay on for a bit longer to ask questions, you're free to do that. We'll stick around for a bit to answer any questions, go over any code, deal with any problems that you might have. So yeah. Yeah, the check-in code is Brave, BRAVE. Um, we'll post the files. I think right after the workshop is over. So yeah, just stick around. Yeah, just check in like 10 or 15 minutes. It should be there on the GitHub.